In this video we're going to have an introduction to the networking topic. 4 types of networks: LAN, WAN, MAN and PAN. So LAN stands for a local area network. This is where computers, devices are connected over a small geographical area. So this may be like a single site, it may be a single building, they may be connected together by cables, it could be a WLAN, a wireless LAN, and they could be connected by wireless. So LANs transmit data very fast but over short distances. A WAN, wide area network, computers are connected together over a large geographical area. So this may be several sites, several towns, and if we take the internet, this is the largest WAN that there is. We've got a MAN, a metropolitan area network. So this is a network that covers a region, citywide. So in terms of in the UK, it may be worth having a look at the Janet backbone, Super Janet. And Super Janet has lots of different MANs. So she has the Norman from the north area of the country, and we've got the Yemen, which is the Yorkshire and Humber metropolitan area network. So have a look at that. Let's research Super Janet backbone. And then we've got a PAN, a personal area network. This is created from 2 devices connecting via Bluetooth. So you create a personal area network. Now networks can be arranged into what's known as a topology. So a topology is the arrangement of computers, cables and other components. It gives a map of the physical network, and the type used affects the type of capabilities of the network and how we can future add and expand to it. For instance, we've got something called the physical bus topology. So LANs can use lots of different layouts, and in the bus all the computers are connected via a single cable. This is known as the backbone cable, and each end is connected to a terminator. What the terminators do, if a signal reaches the terminator stops the signal bouncing back down the cable. So on a bus, a workstation, for instance, sends some data. It leaves this and enters the bus and travels. Copy travels this way and a copy travels that way, and it will go to each device, and if it's destined for that device will read that data. When it reaches the end, the terminator stops the signal bouncing back. If there wasn't a terminator, it would get to the end and the data would come back again. Now the advantage of the bus, it's cheap to install or inexpensive to install because it requires less cable length. There's one single backbone cable and all the other devices are connected to that backbone cable. Bus topologies do not require any additional hardware. The disadvantage though, if the main cable fails, network can no longer be transmitted to any of the nodes. The performance degrades with heavy traffic, and we have something known as data collisions. Basically, going back to our bus, if this device transmits data at the same time as this one, and you've got 2 lots of data, they hit each other, they collide, they cause a surge in voltage on the cable, and that's known as a collision. So the more devices you've got putting on the bus, the more chances of collisions. Imagine this is a road, and it's a 1-lane road, and these different devices are all putting onto this at the same time, and this one's got 1 car coming in the opposite direction. It's going to crash into everything. There's also low security, because on this network everyone can see all the data transmissions, but only devices that want that data actually take it off the bus. Now I mentioned collisions. The greater the number of computers on here, the higher the collision domain, and the collision domain is the likelihood that collisions can occur. Now we talked about protocol before. A protocol is an agreed set of signals and rules, and we can have a type of protocol that detects collisions, and this is known as the CSMA CD protocol. CSMA CD, which stands for carrier sense multiple access with collision detection. And it's all about how the devices use the bus. The sending device, e.g. this one, will listen to the bus. It listens out. Is there any voltage on the cable? If there's any voltage, then that means the bus is busy. So the sending device listens to the cable. If it is quiet, the data is sent. So here we go, this device listens out, there's nothing on this cable, it sends its data. Its data goes. The device will continue to listen to the bus. If the bus has noise, then the sending device continues to listen until the line is quiet. And so that's the first part of it. So that's the carrier sense. It's sensing whether there's any data on there. But both of these devices might have been doing the same thing. They both might have been listening to the bus. They both might realise it's now quiet. They both therefore send data. And one's going this way and one's going that way, and crash! There's a collision. If a collision occurs, which means two devices transmit at the same time, and that data collides, the device closest to the collision sends out a jamming signal. Now what a jamming signal does, it just clears the entire line. Then both devices wait a random amount of time before sending that data again. Now this is the CSMA CD, the Collision Detection Protocol. For AQA Computer Science, we're now looking at the CSMA CA, the Collision Avoidance, and this is to do with wireless transmission. This is good to know as background information in terms of the bus network, but just be aware that you are the CSMA CD in terms of buses, or if it's CSMA CA in terms of wireless transmission, which works slightly different. Here's a really good link to watch an animation of this. I'll just pause just for 2 seconds while you can copy that link down. As well as the bus, we've got one called the star. Now with a star network, we have a central node, and that may be a switch. It could be a computer which acts as a router. It could be a router. And that receives data and transmits with other devices. Now the advantage of a star, if one cable fails, only one workstation is affected. Therefore it's simple to identify and isolate faults. It has consistent performance. There's a reduced collision domain because the devices aren't sharing the same cable, and therefore the likelihood of collisions taking place is much reduced. It would only happen if this device was transmitting to this one and vice versa, then there could be a potential for a collision. Other than that, the collision domain is greatly reduced. It doesn't completely eliminate collisions, but it does reduce it. There is a higher transmission speed compared to a bus. It's easy to add new workstations without disrupting the performance of the network. A star is one of our most favoured network topologies. The disadvantages though, it may be costly to install because you need cable length connecting every device to the central node. And if the central node goes down, network data can no longer be transmitted. Now we've got physical versus logical topology. The physical topology is its actual design, its layout, which is really important when selecting wiring. And the logical is the shape and the path that the data travels and describes how components communicate. So for example, here we got on this diagram the computers on the left. They're all connected with a single cable coming from the switch. So in the physical configuration, the computers on the right hand side, they're separately connected to the switch in a physical star configuration. So this is a physical bus, That's the physical star. Logically, however, the network on the right can be arranged to work like a bus. Each individual cable between the switch and device will act as a bus, and the Ethernet bus protocol can be used to control access to the cable. Even though there are only two devices, the switch and the device at the other end of the individual cable, and that could attempt to put data onto the cable simultaneously. With a logical bus, data cannot be simultaneously transmitted in both directions. When you talk about simultaneous transmission, that's known as duplex. And every station receives all the network traffic. That's known as broadcasting. But only the intended recipient actually accepts it. Devices connected to networks use an IP address, which is a software address. But they also have another address, and that address is known as a MAC address. Now, every single device that has the capability of connecting to a network in any way has a hardware inbuilt address part of it, and that is known as a MAC address, which is a media access control address. Every computer device which is capable of being part of a network must also have a network interface card, an NIC. Here is an example of a MAC address. Unlike an IP address, a MAC address is physical. It cannot be changed. If you access your mobile phone, you'll find a MAC address. If you access, say, a sports tracker, you'll have a MAC address. On your computer, a wireless device, wireless network card will have a different MAC address to an Ethernet network card. MAC addresses is the physical hardware address, whereas an IP address can change. You can have a lease for an IP address, and you can manually set an IP address for an internal network. Therefore, what was somebody's IP address one day might not be their IP address another day, and the MAC address has that complete physical connection. So this video has covered the fundamentals of topologies and networks, focusing on physical versus logical and bus versus star.